All right, let's dive right in. Whether you're cramming for your AI practitioner exam or you're just trying to get your head around one of the biggest topics in tech today, you are in exactly the right place. We're going to do a quick-fire recap of responsible AI. It really all boils down to this one question. We are building these unbelievably powerful tools, but we all know that power without responsibility, well, it can be pretty dangerous. This is the exact problem that the whole field of responsible AI is trying to solve.
So what is responsible AI? Well, at its heart, it's basically a framework. It's a set of rules and principles to make sure our models aren't just powerful, but that they're also ethical, transparent, and most importantly, trustworthy. It's all about building fairness and safety in from the very beginning, not just tacking it on at the end. Okay, so let's start breaking this down. We're going to begin with one of the most fundamental trade-offs in this entire field, that constant push and pull between how transparent a model is and how well it actually performs.
Here we've got two words that are absolutely crucial: transparency and explainability. So, transparency lets you see how the model works, the data it's using, the algorithms. Explainability is different. It helps you understand why it made one specific decision. Think of it like this. Transparency lets you pop the hood of the car and look at the engine, but explainability tells you why the GPS decided to turn left instead of right. You absolutely need both to build trust.
So that sounds pretty logical, right? The more we can see, the more we can understand, the better the AI must be. Well, it's just not that simple. And this is really the core tension you have to get for the exam. And here it is, the core trade-off, laid right out. See, on one hand, you've got these highly transparent models. They're simpler, they're way easier to interpret, but that very simplicity can mean they just aren't powerful enough for really complex jobs. Then, on the other hand, you have the black boxes, these incredibly complex models that can be amazingly accurate, but are so much harder to understand. The real challenge for any AI practitioner is finding that perfect balance for whatever job you're trying to do.
Now, let's switch gears and tackle two other huge concepts that every single modeler has to deal with: bias and variance. This is all about hitting the target, not just accurately, but consistently.
So, let's start with the first piece of the puzzle. What happens when your model is consistently wrong? And I mean wrong in the exact same way over and over again. Yep, that's high bias. It means the model is just too simple for the data, what we call underfitting. Just imagine you're trying to draw a really complex, curvy line, but all you have is a straight ruler. You're just going to miss the mark again and again. Your predictions are systematically off, maybe always too high or always too low.
Okay, so if being too simple is a problem, what do you think happens when a model is way too complex?
And that's where you get high variance, or what we usually call overfitting. This is when the model is so complex that it doesn't just learn the real pattern in the training data, it actually starts to memorize all the random noise too. The result? When it sees brand new data, it performs terribly. It's like a dart player who hits every single random spot on the practice board but can't get anywhere near the bullseye in a real game. So the ultimate goal for anyone building a model is to find that sweet spot. You need a balanced model. It has to be complex enough to actually capture the true patterns, but not so complex that it starts chasing after random noise. Nailing this balance, getting low bias and low variance, that is the holy grail of model training. Okay, let's pivot from those foundational ideas to what's happening right now, on the cutting edge. Generative AI is absolutely everywhere, and it comes with its own very unique set of risks that are super important to know. For your exam, you're definitely going to want to remember these three big ones. First up, you have hallucinations. This is where the AI just makes stuff up, but presents it like it's a solid fact. Second, there's exposure, where the model might accidentally reveal sensitive or confidential data that it was trained on. And third is prompt leaking, which is when the model's own internal instructions or maybe even other users' inputs get exposed by mistake. Each one of these is a massive trust breaker. So we've got all these different challenges: transparency, bias, hallucinations, you name it. How do we pull it all together? How do we actually build something that's truly responsible?
And here's the thing. The answer isn't just a better algorithm or more code. It actually requires a completely different way of thinking. This is where something called human-centered design comes into the picture. It's a philosophy that says we have to put the needs, the safety, and the well-being of people at the absolute center of everything we do, right from the start.
And this human-centered approach is really built on a few core pillars. It's not just about accuracy anymore. We have to start asking bigger questions, like, is the system fair? Can we actually control its outputs? Is it robust enough to handle things we didn't expect? And is there proper governance in place, with clear lines of accountability? These are the really critical questions that a responsible AI practice forces us to answer.
And that leaves us with one final and honestly crucial thought. We've talked about how to balance a model technically, with bias and variance. But the biggest challenge we face might not even be in the code. It's in the data. How do we build fair systems when they're trained on data that comes from a world that is, let's face it, often unfair? That's the question that's really going to define the next chapter of responsible AI.